Pharmaceutical quality control. Chemical instability. Chemical instability implies the lack of any decomposition in the chemical moiety that is incorporated in the formulation drug, preservatives, or excipients. Hydrolysis is the breaking of a chemical bond due to the reaction of water. Most vulnerable groups, for instance, drug type examples. Esters, example, aspirin, alkaloids, nitroglycerin, dexamethasone, sodium phosphate. Lactones, bilocarbon, spironolactone, imides, chloramphenicol, lactams, penicillins, cephalosporins. The most common are esters and imides. Hydrolysis reactions occur quite slowly, but in the presence of acid or alkali, the rate of the reaction increases and significant decomposition can occur. Lidocaine and Brucan, as shown in this figure. Brucan is a good local anesthetic, but its effect is short-lasting because its ester group is rapidly hydrolyzed. Lidocaine contains an amide bond, which is less readily hydrolyzed than Brucan's ester. It is more stable to the effects of hydrolysis, makes it a longer-acting local anesthetic. To reduce hydrolysis, replace liquid dosage forms with the dry powders, followed by reconstitution in water before dispensing. If a drug is known to be susceptible to hydrolysis at room temperature, store in a cool place. Determine the pH of a maximal stability change solvent. Replace water with glycinol, propylene glycol. Aspirin is formulated in propylene glycol. Cyclamic acid is more stable in aqueous solution. Make insoluble form of a drug. Make suspension. Make insoluble form of drug. To increase the stability of a Brucan, penicillin solubility is reduced by addition of citrate, sorbitol, or gluconate. The hydroxys of aspirin produces acetic acid as a product. In the poor storage of aspirin tablets, a small vinegar over time is a sign that hydrolysis is occurring. No aqueous dosage form of aspirin. Add surfactants which form micelles that improve stability. Modify chemical structure. Add complexing agent to increase stability of Brucan, benzocaine, and tetracaine. Caffeine is added to make complex. Oxidation. Oxidation of inorganic and organic compounds explained by a loss of electrons and the loss of a molecule of hydrogen. Most susceptible groups of oxidation, functional group, and examples. Catechols, examples, catecholamines, dopamine, ethers, diethyl ether, thiols, dicaprol BAL, thioethers, chlorpromazine. Factors affecting rates of degradation. pH, the acidity of alkalinity of a solution has a profound influence of the decomposition of the compound. Aspirin buffered salt, maximum stable at a pH of 2.4. Above a pH of 10, the decomposition rate rapidly increases. pH influence rate of oxidation. The system is less readily oxidized when the pH is low. Complexation. Complex formation reduces the rate of hydrolysis and oxidation. For instance, caffeine complexes with local anesthetics such as benzocaine and Brucan to cause a reduction in their rate of hydrolytic degradation. Surfactants, non-ionic, cationic, and anionic surfactants when they added to salt-containing drugs for micelles and drug particles become trapped in micelle. The hydrolytic group OH cannot penetrate micelle cover and reach drug particles. Hydrolysis rate decrease. Presence of heavy metals. Heavy metals such as copper, iron, cobalt, and nickel increase the rate of formation of free radicals and enhance oxidative decomposition. Amphotericin B is oxidized by peroxides. Light and humidity. Light, especially ultraviolet light, enhances photolysis, and humidity enhances hydrolytic decomposition. Presence of unsaturated bonds. The most susceptible are phenolic compounds: morphine, phenolphthalein, steroids, and ceterols. Antibiotics like tetracycline, iconazole nitrate and miconazole nitrate, simvastatin, polyantibiotics such as amphotericin B, fixed and volatile oils, phenothiazins, catecholamin, adrenaline, noradrenaline, methyl dopa oxidized to quinones, vitamins, riboflavin, and ascorbic acid are susceptible for photo oxidation. Stabilization of drugs against hydrolysis and oxidation. Temperature. All of the drug products are stored at suitable temperature to avoid thermal acceleration of the composition. Notice that: room temperature, cool storage, and cold storage. Storage temperature: deep freeze minus than 15 Celsius degree, cold 2 to 8 Celsius degree, cool 8 to 25 Celsius degree, room temperature 25 Celsius degree, warm 30 to 40 Celsius degree, hot more than 40 Celsius degree. Light sensitive materials are stored in amber bottles. Humidity: packing materials are chosen, usually glass and plastic, to prevent exposure of drug products to high humid condition. Oxygen: proper packing, keeping the oxygen content of sol less and leaving very little head space in the bottle above the drug products are methods of fight against oxidation. Chelating agents. Chelating agents form complexes with heavy metal ions and prevent them from catalyzing oxidative decomposition. For instance, ethylene diamine tetracetic acid, EDTA, derivatives and salts, citric acid and tetracic acid. Solvents: by addition of a suitable solvent, hydrolysis rate decrease. Antioxidants: they rated the oxidation process. Kinds of antioxidants. Natural antioxidants: tocopherols, nordihydroguaric acid, NDGA, sacimol, gusibol. Synthetic antioxidants: butylated hydroxyanisole, BHA, butylated hydroxytoluene, BHT, propyl gallate, BJ, tertiary butyl hydroquinone, TBHQ. Decarboxylation: substances having carboxylic acid group decarboxylate by giving off CO2. 4-aminosilicic acid is an example for phosgene decarboxylate in acidic medium. Drugs containing bicarbonate NaHCO3 are not sterilized by autoclave. Broken is if sterilized at high temperature, convert to aniline brown color. Isomerization: the process of transformation of one molecule into another molecule which has exactly the same atoms, but atoms are rearranged. Bilocarbena: epimerize into isobilocarbena. Tetracycline epimerize in acidic pH to 4 tetracycline, which is toxic. L-adrenaline more active, isomerize into D-adrenaline less active. Loss of activity adrenaline at low pH. D-tubocurarin more active, change to L-tubocurarin less active. Hyoscyamine more active, change into racemic. DL-atropine when heated in basic pH less active. Geometric isomerization is possible form says most active to trances. Dehydration means loss of water from the compound, mainly affect dissolution and absorption since it affects crystal form. Hexose sugars form 5-hydroxymethyl furfural when dehydrated. Erythromycin acid catalyzed dehydration. Prostaglandins E1, E2 dehydrate and isomerize. Absorption of CO2. Hexabarbital sodium solid in water absorbs carbon dioxide from air and form hexabarbital insoluble precipitate. Polymerization. The process where two or more identical drug molecules combine together to form a complex molecule. Hydrate of formaldehyde. Formaldehyde polymerize in aqueous solution into paraformaldehyde white precipitate. Could be prevented by addition of methanol. At high temperature, amoxicillin and ampicillin may polymerize, causing shock and sensitivity. Thanks for listening.